Welcome to this video on binary multiplication. In the exam you need to know how to multiply any given binary numbers. Okay, so before we have a look at binary numbers, let's just remind ourselves how to actually multiply in denary, because it's going to help us. So, purple pen. I have got 12 times 4. Okay, now 12 times 4 equals 48. How did I know that? Well, when I was in primary school I was told to write it like this, and I times the ones column, 2 times 4, that gives me 8, and then I will times the tens column, 10 times 4, so that was 2 times 4, and then I have to do 10 times 4, which will give me 40, and then I add these two together, which gives me 48. Now that's nice and simple, but then what happens when we get numbers such as 12 times 14, for example? And unless you know your 12 or 14 times table, you need to be able to work it out like this. We do 12 times 4, I know that's 48, 12 times 10, which is 120. Can you see with the numbers from base 10? And you'd probably be aware of this anyway, because you were told at school whenever you would times in by 10, it means you stick a 0 on the end. If you times by 100, you stick 2 zeros on the end. Well, it's the same in binary. I'm going to explain that in a little bit in a minute. But the reason being is because this is base 10, this is where the numbers flip over. So the whole number shifts one place to the left. The whole number shifts. If I had 8 times 1, okay, gives me 8. But if I times that by 10, it's 80. If I times that by 100, it's 800, and so on and so forth. You can see the relationship with the numbers there. Okay, they're shifting over. And if we put that with our ones, tens, hundreds, thousands column there, you would see that 8 times 1 is just 8, okay, but then times by 10 it shifts, jumps over, the 0 goes there, times 100, it shifts. I've now got 8 lots of 100, 0 lots of 10, 0 lots of 1. If I times it by 1000, it shifts. 8 lots of 1000, 0 lots of 100, 0 lots of 10, 0 lots of 1. Because in base 10, 10 is the number at which it flips over. Now, the same thing happens in binary. If I was going to multiply a binary number by another binary number, I put these numbers at the top here, the same way, like this. And I have to do the same thing. I say 101 times 0. And that equals 0. Anything times by 0 is 0. If you've got no lots of anything, you've got nothing. Now what do I need to do? I need to times 1. Okay, 101 by 2. Remember 10 is 2. Let's remind ourselves of that. 1, 2, 4, 8. 1, 2, 4, 8. It's 10 because 10 is 2. 1, 0, 1 times by 2. The 0 shifts a number over because we're timesing it by 2, and 2 is the base number, so we have a shift to the left. It's called a bit shift. Shifts over. Let's try another example. A little bit more complicated example, only marginally more complicated. 1, 2, 4, 8. One, 0, 1. But this time I'm going to times it by 3. Why is that 3? 1 lot of 2, 1 lot of 1. So what do I start with? 101 times by 1. Anything times by 1, if I've only got one lot of this, I'm only ever going to have this one. So let's put that in. Now what do I need to times it by? 101 times by 2. The 0. 2 is the base number, which means we're going to have a shift one place to the left. And that is our number. 5. Remember, this is base 10, yeah? Times 3. What does it equal? We need to add them up to find out. 1 lot of 1, 1 lot of 2, 1 lot of 4, 1 lot of 8. So this should come out, 5 times 3 should be 15. How do I know this is 15 without having to add them all up? Because this was all ones, so therefore it's going to be 1 less than the next most significant bit. 1 less than 16 is going to be 15. You could add them up if you want. Let's try another example. Which pen to use? This one. Okay. 1, 1, 0, 1 times 1, 1, 0. This number 1, 1, 0, 1 times by 0. That's nice and easy. It's nothing. 1, 1, 0, 1 times 2 seconds. Lid wouldn't go on the pen. That was me spitting the pen lid out, by the way. 1, 1, 0, 1 times 2. Bit shift. Yes? The 0 on the end. Okay? Now I've got 1, 1, 0, 1 times 4. You see that? How many times does it need to be shifted? Twice. Now I need to add them up. Can you see them all in there? So now I'm going to add them all up. And this is where your advanced binary addition is going to help you. Okay. How many lots of 1 have I got? 0. Nice and easy. How many lots of 2 have I got? I'm only looking this bit, by the way. This bit here. Only here. Remember, that's the sum. How many lots of 2? 1. How many lots of 4? 1 lot of 4. Ignore that. That's a mistake. How many lots of 8? 1. How many lots of 16? 1 lot of 16 plus another lot of 16 gives me 32, which means I've got 1 lot of 32. There's my little carry. 0 lots of 16. How many lots of 32 have I got? 1 plus my carry lot of 32. 32 plus 32 is 64. 0 lots of 32, 1 lot of 64, and that is my answer. Okay. When you're doing your binary addition, if you use the advanced method, that will make it far more simpler. Okay, that is how you do binary addition. Remembering it is that simple. It is shifting it all of the time. It's either timesing it by 1, timesing it by 2, timesing it by 4, so on and so forth. All you're doing is you're shifting it over to the left, or it's going to be 0, or it's going to remain the same. That's as hard as it gets. Practice with the ones that are on the PowerPoint and the learning platform. Make ones up for yourself. Have a look online for some examples and get this into your head. Okay, until next time.